doing here is a sort of a typical problem on dealing with continuity. And so this is from section 2.4 from OpenStax Calc, volume 1. This is section 2.4. Other books, not OpenStax book, but other books will have it in a slightly different section. But anyway, okay. Let's go through the three-part definition of continuity for a function in number A. Let me zoom in better. So let's go for it. Please feel free to jump in. What's the first thing I can do for the three-part definition? What do you say? Who will tell me? What can we have there?
It has to be defined.
F of A is defined. That's the same thing as saying A is in the domain of F. Both are good to write down. What's the next thing?
The limit as x approaches A of f of x exists.
That's exactly right. And please, everybody, be careful that you write it down the way I'm writing it here. Sometimes people develop their own shorthand, but I want you to write it down this way, right? LIM, the whole thing, just like that. And finally, number 3, what can we write down? Those two are equal to each other. That the limit as x approaches A of f of x is equal to f of A. It's saying that to calculate the limit, I could plug in x equals A. I mean that's one thing it's saying. So that if I want to find the limit of f of x as x approaches A, I plug in A. Next, we're going to go on to a what's more or less an algebra problem, but not a super easy one. Sort of could be considered tricky. Actually, now I look at it, it looks really sort of tricky. Okay, hold on. I might do some background. This is from an old test, and I have a feeling that later on I decided that this wasn't even a very good problem, but I guess I'm stuck with it. I mean, the functions I chose weren't good. I mean, the first one is y equals 2 to the x. So we can, you can plot points. So x less than 1 is over here or around over here. Okay, even though it's x less than 1, I could put 2 to the 1 and get 2. I'm going to put a okay, I'll just put a few points. I think that we can, maybe a lot of times you can just do these in your head, but two to the 1 is 2, 2 to the 0 is 1, 2 to the negative 1 is a half. All right, so let me try to get a different color. And I'm stopping at 1, and I put that little open circle there. So that's that one. Now, I feel like I need more space, but I'll just steal some space from above here for y equals negative x minus 1 squared plus 2. Okay, that is a downward facing parabola. The form is a standard form, and look at the way it's written. I have x minus 1 squared. X minus 1 squared, not thinking about the negative for now, just x minus 1 squared. X minus 1 squared itself will never be negative. It has its minimum value when x equals 1, because then I get 0. 0 minus 1. When x is 1, I get 1 minus 1 is 0. So it has its minimum value at 0, or when x minus 1 squared is 0, which is when x is 1. Okay. But since it has a minus there, that means it has its maximum value, actually. It's a downward facing parabola. It's going to have its maximum value when x is 1. And when x equals 1, we can say y is 2. I just did an outline for showing that the vertex is 1, 2. I said it sort of fast. Another way is that you recognize the standard form here. So anyway, starting at this, I go to the right one and down 1, to the left one and down 1. I go to the right by 2, I go down by 4, because 2 squared is 4. You can plot more points. Okay, that's y equals negative parentheses x minus 1 squared plus 2. The vertex is negative, is 1, 2. All right, so then over here, I'm going to sketch that graph, and it might not come out as nice, but let's see, this is for x greater than 1, so I'm just going to plug that in. And by the way, you can plot points on the side of the paper. Okay. So when x is greater than 1, we have y equals negative x minus 1 squared plus 2. I'm going too slow, but anyway, it's okay. And then when x equals 1, I have this point over here, which is 1, 1. Alrighty. So far, so good. So that's the point 1, 1. Okay, let's answer this question. Where is f discontinuous? Are there any questions on that, first of all? Your answer needs to pass the vertical line test, by the way. So there should be no overlapping, even though you might be, I don't know, people might be tempted to do overlap or something like that. No, don't do that. That's the best. The vertical line test. And there's no, this function is defined for all x. So there's nothing except that hole in the graph. Okay, what's wrong with this? Where is this guy discontinuous? Where's it discontinuous? F is discontinuous, which one way is to think of that is you have to lift your pencil at x equals where?
1.
1. I was about to write down 0 for some reason. I don't know. I think I did another problem, but no, 1. I don't know why I was at 1. Because what's the problem? What is the problem? Let's go, what?
I was going to say it's removable.
It's removable. But let's look at this 3-part definition. Thank you. It is removable. That's a good one. Okay. Let's look at the 3-part definition. Is f of 1 defined? Let's go through these guys here. Is f of 1 defined? What's f of 1?
1.
So that one works. Does the limit exist? What's the limit?
2.
The limit's 2. So what's the problem? Does the limit equal the value of the function?
No.
No.
No, they're not the same. Okay. You don't have to say why. And also, I know there's a bunch of homework problems on removable discontinuity, jump, and infinite discontinuity. I think I'll put that on the test. It's not on this practice test, but I think I'm going to put one of those on the test. I mean, there's a whole bunch of homework problems on this. So, okay. So anyway, let's